Okay, dear students, let us see what is there in this question. A box of mass m is held on top of an inclined plane of height h. Friction between the inclined plane and the box is negligible. The box slides down the plane until it reaches ground level with a speed of v. It continues sliding along the ground, which has a coefficient of friction mu, until it comes to a complete stop after a distance of s meter. Which of the following options is correct expression for the coefficient of friction? Okay, so we need to find the correct expression for the coefficient of friction, and we know that the coefficient of friction is mu, so we need to find this mu now. So this topic relates to work energy power topic, and so we will be talking in the terms of energy and the negative work that is done by friction. So what is now happening here? This is the horizontal ground and this is the inclined plane. So this is the box that started sliding down. Okay, and so now I am not going for the forces here. I'm not considering forces at all. I am only considering energy. So we know that the friction between the inclined plane and the box is negligible, so energy is not wasted anywhere. So you can say that the potential energy here, like if this distance is h, so potential energy here gets converted into kinetic energy when the box starts its horizontal motion here. So the kinetic energy initial is equal to the potential energy initial here. So that can be taken as mgh. Anyways, so this kinetic energy is now lost because after some time, after going some distance, like let us say after reaching this much of the length, it stops and all of the kinetic energy is lost and the velocity becomes zero at that point. So where does the energy go? Like this potential energy was converted into kinetic energy cent percent, no doubt about it. And then this kinetic energy was lost due to the friction. So what is actually happening when the box was moving here? You see the friction was acting backwards, but the motion was going in the forward direction. So I can say that friction was backwards, but the displacement is forward. So it is a clear-cut case of negative work. So all of the kinetic energy is lost in that work. So I can say that the potential energy is equal to kinetic energy, and this kinetic energy is lost in the work. So I can say negative F into S. So we can skip this negative mark now because we are considering only magnitudes here. That is why, as for the calculation. So we will see. So the question is now whether H is given until it comes S, and here the height is given as h. So definitely mgh is the potential energy that will be equated with the friction is going to be mu s into m into g, because at this time the normal reaction is equal to weight mg. So r can be written as mg, mu mg into the distance traveled, and which is s. So s is the distance traveled. So this will be the equation. M and M gets cancelled out and we need to find mu. So mu should be equal to, uh, okay, the H was not required. Okay, I can do that. Let us cancel G and G. So mu is equal to H by S. Yes. The second option will be correct. But because some of our options are given in the terms of V also, we have to consider the second thing also, like the kinetic energy equated with the work here. So it will be half mv square. It will be equal to mu m into g into s. So now I'm using this equation. Okay, so from here we reach the conclusion that mu can be taken as v square by 2 2gs. So this option is wrong and this option is also wrong. So mu is coming out to be v square divided by 2gs. So this is also correct, and mu is equal to h by s is also correct. So our second option is correct option. So my dear students, this is Professor Varun. Please subscribe to the YouTube channel. You can reach me on Discord as well as on WhatsApp. All the best.